Hi, everybody. This is JJ with ASUS, and we're back again for another PC DIY-centric live stream. This time around, we're going to be talking about all things DDR5. We've gone ahead and invited one of the absolute best partners in the industry with Crucial by Micron. We've got two fantastic guys from their team to help to go ahead and kind of dive into DDR5 and be able to give us, I think, a greater understanding in terms of a lot of the kind of specifications, the misconceptions, where DDR5 is at and where it's going to be going, and a lot more of the real premise points that I think a lot of you in the community are interested in. And I think the great thing is here, we're also going to give a little bit more context to kind of understanding DDR5 throughout the entirety of the industry. So, ASUS manufactures motherboards, laptops, mini PCs, and we're seeing all of these now transition over to DDR5. So let's go ahead and invite our friends over here from the Crucial and Micron team to be able to go ahead and not only introduce themselves, but as I noted, help to give us a little bit of greater understanding regarding all things DDR5. So thanks, guys, for joining us for this stream. I'm pretty excited about this. It's now been a few months since the introduction of kind of DDR5, especially on the desktop side, but we're now seeing a real big kind of broad deployment, especially from our perspective and also from the industry, now seeing it in everything from desktop motherboards to laptops to mini PC solutions, right? And I think it's a really exciting time. So great to have you here to be able to speak to your guys' kind of really industry leadership at really being leaders within this space. So why don't you guys introduce yourselves?
Hi, everyone. I'm Karthik, the Product Marketing Manager for Crucial DRAM.
And I'm Ben, also known as Benny Boy. I work marketing, social, also with community. Anything related to Crucial here. If you have questions about products, I'm usually a good resource. So.
Very cool, very cool. So for for me, I'm getting pretty close to now my 15th year with ASUS. So I've been with us for a pretty good chunk of time, be able to see a lot of memory transitions, been able to see a lot of chipset platforms. And for you guys, how long guys have you been with Crucial Micron?
So I've been with Micron almost 10 years, but I've been in the industry working with PC gaming, component hardwares. I've worked with NVIDIA, a couple other vendors for, I guess, almost 20 years now. So I've been around the scene for a long time, but yeah, with Micron, almost 10 years now.
That actually makes me feel more younger than you guys. Well, compared to you guys, I've been in this industry only for about 2.5 years, basically when I joined Micron and the Crucial team.
Okay, so still acclimating yourself, but of course,
yes, yes.
in the tech industry, right? 1 year, it's almost maybe equivalent sometimes to I think 3 years in the real world, just because so much stuff is compacted sometimes within 1 year in terms of how much focus we do on things. But I think that actually brings us to kind of an interesting point to now kind of, before we get into, I think, the deeper dive, right, in terms of DDR5 is kind of talking a little bit about the current kind of state where we're at, where we're kind of transitioning, because DDR4 is still very much kind of the industry standard, right? And it's very prevalent across all the ecosystems that we've talked about, right? But it's now been quite some time, right? I think, DDR4, we saw the introduction of it as kind of a specification and kind of broader adoption, right? About 2014, 2015 timeframe is when we saw it kind of get out there in terms of the market. And now we're going into, now 2022, and we are now kind of moving into the DDR5 era, right? And what does that look like, I think, for users? The interesting thing is I think that it's not necessarily going to be exclusionary to one or the other, right? You guys, of course, continue to produce both solutions, right? DDR4 and DDR5. But we, as I noted, are going to be transitioning pretty much everything now, where we already know that Intel's platforms, they're all committed to the DDR5 specification. AMD has gone ahead and also made their announcement for the next generation AM5 platforms, which we're excited about, which will also be based on DDR5. On the laptop side, we've gone ahead and already, again, transitioned to DDR5 for both Intel and AMD-based solutions. And even things like our mini PCs are also transitioning to DDR5. So I think overall, we're not really waiting on anything. It's now really going to be about setting that foundation of what really the benefits are going to be and where we're going to be moving towards in terms of what DDR5 is going to be offering us, because there's quite a number, I think, of improvements that are based in the specification that are really exciting. So from your guys' perspective, where do you see kind of the transition? Do you think that, I know that there was a little bit of kind of teething pains for some people in terms of their perspective on the initial availability, things along those lines. But right now, I think the viability in terms of, you could go straight to Amazon, you could go to Newegg, you guys to your guys' web store, and you can pick up a kit of memory, right? It's not an issue anymore. So where are you guys thinking about right now in this current kind of transition state?
Well, JJ, that's a great question. As you said earlier, when all memory vendors launched DDR5 in the market, we suddenly hit a few snags because right out the gate, we pretty much across the industry, there were industry-wide shortages of power management chips, and that pretty much put all memory vendors in a tough spot to be able to supply a good amount of DDR5 modules into the market for all enthusiasts and mainstream users. So it's suffice it to say that we have come to a point where we have overcome those challenges in terms of procuring enough non-DRAM components. But in recent times, our supply, specifically for Crucial DDR5, it has significantly improved compared to when we launched it.
Yeah, and I mean the industry as a whole, we're in a much better spot we are right now than we were 10 months ago. Normally transitions aren't always smooth, but this one definitely, there were some hiccups along the way. And, you throw in people like scalpers on top of it, which were already taking, advantage of certain markets, inflating prices. And then, you have people online talking about, $800 32 gig kits. Like, this is ridiculous. Like, why would I ever buy DDR5? But, obviously we're in a much different scenario now. And especially with, with Zen 5 coming on board in the near future, I think we're going to be in a much better position where it's natural and it makes sense for people to make that jump to the next iteration in memory technology. So it's cool. We're in a good spot right now, and like you said, DDR5 is rolling out everywhere, and it is now.
Very cool. So yeah, I mean, I think at the end of the day, the easiest way for any of those that are kind of watching is that, again, you can feel confident and comfortable. You don't have to worry about that if maybe initially you saw kind of maybe information out there that maybe it wasn't ready from a kind of stability or maturity, interoperability standpoint. All the validation's been done. We're continually working with our partners to be able to ensure a great kind of drop-in experience from, kind of a plug-and-play experience. And I think actually in a lot of ways, as we probably jump into the primer, there's actually some really kind of nice inherent benefits in terms of, I think, DDR5 at affording users kind of a guaranteed minimum performance envelope. Compared actually oddly enough to the way the DDR4 works, because there are some differences in terms of kind of the expected frequency or the expected kind of operating parameters that the memory has when you purchase a kit, and how that actually translates into what happens when you put that into a system. And it doesn't necessarily always equate, right? Many times you might buy like a 3200 mega transfer kit, but you drop it into a board and it might be running a 2133. That's not necessarily the case actually with DDR5. The great thing is right now, if you're going to buy 4800, you're going to get 4800 pretty much out of the box in terms of that kind of core experience. There are a couple, of course, things to always keep in mind in that regard, but a lot of really cool kind of aspects there that overall you can feel comfortable and confident whether you're adopting into motherboard, laptop, whatever kind of the platform is, you're going to be good to go. So I think from here, guys, we're going to give you guys the opportunity to actually get a little bit more technical and dive into actually some of the really kind of cool aspects to give us a greater understanding of, I think, the benefits of DDR5, right? Because I think, one, there was a lot of just general conversation of, focus, I think, of course, on always, operating performance metrics. But at the same time, maybe some of the information that might have been lost was having an understanding of where actually there are specific improvements in terms of the way that maybe the efficiency or the bus operates, even density improvements, right? Which I think are actually really valuable for this platform, and overall are going to be beneficial to users. So let's get ready to go ahead and dive into DDR5 with our primer. Sounds good?
Sounds great.
Sure. This might be quite a long answer because there's a lot to talk about when it comes to this topic. What's DDR5 and what problem does it solve and why is it needed? So we'll have to start from the top. Now, there is a problem with DDR4, meaning it doesn't scale memory bandwidth for the next generation of CPUs, multi-core CPUs. We know that the computing needs for are exponentially increasing or skyrocketing even. And to tackle those challenges, CPU companies are adding more CPU cores. And as you add more CPU cores, DDR4's memory bandwidth per CPU core continues to decline. So you take 3200 and you put more cores on that. For example, if you were to have an 8-core CPU and you have 2 sticks of DDR4 3200 CL22, and you get about, let's say, 4 gigabyte per second per CPU core. Now, if you don't change the memory, you just switched from 8 to 16 core CPU, you just cut your bandwidth by half per CPU core. So from 4 gigabyte per second per core, you've now gone to 2 gigabyte per second per core. That's the problem with DDR4 technology, because it doesn't scale bandwidth when you're actually increasing the number of CPU cores, because you want more processing power for the next generation of applications and workflows. This is the problem that DDR5 solves. So for the same transition from the 8-core CPU to a 16-core CPU, if customers were to adopt a DDR4 4800 CL40 DIMMs, they are essentially maintaining the 4 gigabyte per second per CPU core bandwidth. That's what it means. So when transitioning from DDR4 to DDR5, what it means is that you're able to scale your memory bandwidth as you're increasing your CPU core. So the next generation of multi-core CPUs need next-gen memory, and hence DDR5. So that by itself is a good benefit of DDR5. What does it enable users to do? To be able to sustain and scale the memory bandwidth for the next generation of multi-core CPUs. Now, you might be wondering, what is a bandwidth and what are we talking about? Bandwidth, all that really means is that if I were to give an illustrative example, you can visualize a water pipe, and pumping water faster is one thing, but improving the efficiency of the water being transferred from point A to B by increasing the diameter of the pipe. Now, you're not just pumping faster by spending more energy, but you're actually being efficient and reducing the amount of effort that you use to pump a lot of water to transfer from point A to point B by increasing the diameter of the pipe. Now,
so going from visual, right? Going from something small to going to something much
big,
larger.
Exactly, and now you have the benefits of actually transferring more water from point A to point B. So that's the illustrative example of benefits of DDR5. Now, that is not to say that it's going to make every workload or application faster. There are some workflows, some applications that are not memory intensive, and they're not going to go access the RAM module. So you will not see benefits on certain workloads, and that is true even for DDR4 or DDR3 memory technologies. So suffice it to say,
to that point, though, right? Just to kind of, because I know this is something that people kind of are going to kind of wonder about, right? Is that this is also in alignment with what you've said. Was you talk about the kind of the lockstep kind of evolution where DDR5 has been designed for the current state of multi-core based processors, right? High core count multi-core processors. Again, we can go back to that introduction of 2014. We were talking about, the common kind of CPU configuration might have still only really been a quad core, right? Maybe kind of entry into 4-core to 8-thread based units, right? And now we're entering into spaces where, we've got platforms where you're talking, as you noted, 16 cores, but then you implement things like hyper-threading, you're talking 32, right? And then we talk about platforms that even have more. And at the same time, just like we see some applications aren't necessarily always benefiting from cores, they might still be frequency dependent and IPC dependent, right? When those applications, as they're continuing to become more and more present, because we now have more abundant cores across all price bands, which is very important, right? It used to be that you might had a lot of cores, but it was only at the very top end of the spectrum. But now you could adopt in even a Core i3, right? And you can have actually quite a number of cores, right? Or an upcoming AMD platform, you can have a lot of cores. So we're going to continue to see that improvement. So, even on our end, we're seeing, everything from, After Effects to DaVinci Resolve to even web browsing, right? Which is now actually becoming more multi-threaded, be able to benefit from this. So I think the great thing is that you can see benefits that exist right now, but the actual performance envelope is only going to get better. It's not going to get worse. It's only going to get better. So that's an important thing to keep in mind, is that even right now, in a weird way, a lot of times technology isn't necessarily going to improve or get faster, but actually users will even continue to get a better experience, I really think, over the next year or two, as we continue to see more refinements and improvements, not only within operating system environments, but application optimization, right? So I just wanted to touch in on a little bit of what you did there in terms of really giving us a great illustration, understanding the bandwidth and the scaling limitations that we have from DDR4 to DDR5. But feel free, go ahead.
Yeah, and on that application front, like, especially me being a gamer, like, I'm really excited for what Microsoft's doing with Windows 11 and some of the things they're going to implement. not only from a memory front, but a storage front. So basically where you can get tangible frame increases from having faster hardware. So some of the things, those new implementations we're seeing with software design from the OS level, application level, again, they're all going to trickle over and get you more performance at the end of the day. So, but yeah, it's an exciting front, and it's cool, especially with the new Ryzen around the corner. You know, I think it's a really cool and awesome time to be jumping on the mini core bandwagon and getting some fast memory to support it. So it's exciting stuff.
Yeah. So why don't we go ahead and dive maybe a little bit into understanding some of the technical differences in terms of the actual memory itself, right? So there are some changes in terms of things like, same bank refresh, right? There's a difference in terms of the actual bit bus. Why don't we go ahead and go in a little bit into that? Because I think some of these things are important and they actually also affect performance. You talked a bit about efficiency, and to give some interesting kind of performance metrics, right? I know a lot of people have focused on, let's say, the performance envelope that's present on desktops, and that makes sense, but actually very interesting, we're really kind of the world's leading manufacturer of gaming laptops. And one thing that we saw that was really interesting when DDR5 got implemented is because of its effective efficiency. Actually, there's a really interesting thing that came as a byproduct of kind of implementing DDR5. So historically in laptops, you really wanted to run optimally, quote unquote, in dual channel configuration. You wanted to have two DIMMs present within the laptop to get the best gaming performance. In a DDR5 laptop, we actually see that the performance is almost parity. It means that we can literally almost run one single DIMM in that laptop, and you're getting effectively almost the same performance. And you get a little bit of a bump when you put in a secondary DIMM, but it's actually not that much of a performance increase. And this is a very stark difference in comparison to DDR4. Even just from a generation ago. So we could take, our SCAR gaming laptops, and you would have a noticeable uplift in performance just by putting in that secondary DIMM. DDR5, that's actually not the case, right? And so I want to help people understand, well, why is that? Because it might seem a little bit counterintuitive, because historically, for the last, 5-6 years, right, we would always think that's always going to be better, but it doesn't tell the whole story without understanding, I think, some of the actual efficiency improvements that have been inherently made within DDR5.
Yeah, so like especially when we're looking at DDR5, like Karthik, I'm looking at this memory and I'm like, oh, that speed's awesome, but man, CL40, what's going on there? Why are we doubling the CLs from a previous generation? So tell me what's going on there.
I know we've doubled the latency by almost twice, right? It's worse than DDR4. Well, sorry to disappoint. It might have been the terrible naming convention for the number of clock cycles. As I said, CAS latency, it just means that what's the number of clock cycles. But if your clock cycle time has dramatically reduced, you're basically normalizing the resultant latency of DDR5 modules. Now, the CL40, it's just a spec. But how does it translate into latency? Very few users actually understand this, and you bring up a very good topic, and this has been a sore spot for so many users in the community, and I'll be more than happy to walk you through that. Now, as I said earlier, the true memory latency is a function of both the RAM speed and also the CAS latency. So your clock cycles and the clock cycle time. Now, by going faster, you're basically normalizing the true memory latency compared to DDR4 3200 CL22. The true memory latency for that DDR4 3200 CL22 is about roughly 13 nanoseconds. And for a DDR5 4800 CL40, this module from Crucial, this has a true memory latency of about 16 nanoseconds. So some people might be thinking, well, that's a 20%, 21% increase in the true memory latency. Well, that's still not entirely the big picture, because the latency that users actually experience is at the system level. And let's say, JJ, you're familiar with this concept, one DPC, two SPC, and when you're actually installing two memory modules in a dual channel mode, your system level latency is a combination of the host memory controller features, its behaviors, your module rank or module speed, and the module's CAS latency. Is a combination of all of these factors. And there is an article out at anandtech.com where they have tested the latest Alder Lake DDR4 system and the system latency of an Alder Lake DDR5 system. What they have found out is that the system level latency of an Alder Lake DDR4 system is about 90 nanoseconds, and the Alder Lake DDR5 system gives a latency of about 92.8 nanoseconds. It's only roughly about 3 nanoseconds more, and what they have said is pretty much in alignment with our expectations, because we expect at the system level, it's only about 3% increase in latency. What does this mean? What does this mean for our users in terms of real customer experience? Is that in real world conditions, none of these matter, because in synthetic benchmarks like this, you will find all the minute differences in latency, and we can keep arguing about this, but it comes to a point of, does 3% increase in latency really affect your system performance in whatever applications or programs you're running in the real world condition? Not exactly. So it suffices to say DDR5 provides the huge advantage over DDR4 in terms of bandwidth, and now we have gone into latency. So virtually DDR5 has the same latency as DDR4. So almost no downsides virtually, but you can get huge benefits in terms of memory bandwidth. That's what DDR5 is all about.
And I think to that point, right, another thing to kind of also keep in mind when we're having this conversation is that a lot of people want to throw around different kind of values that aren't necessarily also what I would say is kind of the industry standard kind of value set that exists not only, again, on things like motherboards, but even things on laptops, right? So you've done a great job to illustrate that when we're talking about kind of the standard normalized values, right, we should be looking at what the official rated specifications are from the actual CPU, right? Because that's defined within the memory controller. And that tells us actually the specific operating target that is guaranteed. Because of course, there's always things like overclocking, specially kind of binned or tuned kits, but these exist outside of a guaranteed envelope, right? They may be possible,
Correct.
but they aren't guaranteed. So an example of this is we'll get people to come out and then be like, but I can go buy this kit that has, CL16 or CL14, or it might be 3600. Well, both for Intel and AMD, even on their current DDR4 enabled platforms, the maximum official max memory divider supported, right, is 3200 megatransfers. That's the guaranteed specification that they're assuring you that regardless which motherboard, which CPU you buy, that's going to be your guaranteed experience, right? Now, when we take that, as you noted, right, that's quite a big difference when we then compare that to 4800, right? In terms of 4800 megatransfers, that's a huge jump up in terms of the amount of bandwidth that's being supplied when we go from a pure stock to a pure stock perspective. So that's an assured, guaranteed experience. There's also, I think, some little bit of a gray area that people forget, that even to reach some of those very, very high next level performance values for even DDR4, right, you also have to heavily screen and bin those memory chips. So example is, we haven't, I think, talked about voltage, but you guys can, of course, help to detail this as well. But there's a voltage difference, right? One of the other really nice benefits of DDR5 is improvement in efficiency, right? Where you have a lower operating voltage, which is really not maybe that much of a value add for the desktop, right? But on laptops, this is a big win. It helps to maximize, overall, battery life, which is, of course, something that we always want, better battery life, right? But if we take a look again at something like DDR4 and you wanted to have something like a, CL14 kit, guess what? That might be operating at like 1.45 to 1.5 volts, right?
True.
Super screened, very, very, and also proportionally, wouldn't be a cheap kit of memory. It would be very expensive because the manufacturers, when they produce it, have to go through, a far more complicated process to kind of bin and screen that out, right? So I think this is kind of really important point to keep in mind, is that we're talking here about an assured baseline, right? That between DDR4 to DDR5, when you look at it from that pure stock perspective, there's not really almost any scenario that you're ever getting less performance. You're always getting pretty much better performance, lower, power consumption, right? So it's overall really a win-win. It only gets into a little bit more of these gray areas when you start getting into these other kind of maybe performance tuning variables, which are much more conditional, right?
Yeah, I mean, and And again, this is all on with the back banner of, hey, next iteration, next CPU, where we're talking about Raptor Lake, Ryzen, like you're not even going to have the option at DDR4. So it's kind of like moot at that point. It's like DDR5 is enabling these next generation platforms that are going to drive even more performance that previous generations DDR4s just won't even be able to touch. So it's cool to keep that in mind. And I like your point of talking about like, hey, DDR5, it's a whole ecosystem. It's going to be in your laptops. It's even going to be in your phones. And those, you know, those performance improvements with voltages and whatnot are all going to be things that we we as consumers really care about. As a gamer, yeah, I have a 900, 800 watt, power supply. I don't really care about that voltage increases, but for everyone else, it's some really cool stuff there. So,
absolutely. And JJ, I do would like to touch real quick on the question that you had asked in our earlier section. What are some of the technical differences? And I think I may have skipped over that real quick. So compared to DDR4, DDR5 memory technology has twice the amount of memory banks, memory bank groups, and twice the amount of burst length. And you also have 2 independent 32-bit channels for non-ECC memory modules. Instead of a DDR4, we only had one 64-bit channel. Now, all of this just improves the bus efficiency of DDR5. Remember how I said DDR5 breaks through all of these limitations of DDR4 for the next generation of CPUs. And because of these innovations, same bank refresh, 2 independent 32-bit channels, twice the amount of banks, bank groups, burst length, all of this, what does it mean? It makes the memory channel or the bus efficiency super high compared to DDR4, and that's what's enabling all of these advantages that you talked about earlier, JJ. So I just wanted to real quick touch base on that.
This is great because I think these are often overlooked. Like you said, we've got the 2 independent 32-bit channels, right? This is a considerable bump up from the DDR4 spec, right? Of course, the same bank refresh, right? And of course, also the burst length. And I think that goes hand in hand with what you've noted, right? Which is part of the reason why we can actually see, especially when we are using multi-threaded applications that are really asking for that bandwidth, why the performance increase. And even with some sites, as you noted, a good example was Anantech. I remember when they were doing some of their reviews, they reached out to us and it was like, some of these performance uplifts actually seem quite a bit larger than we would even have thought. And that's partially because the bandwidth, when you're now increasing it, it's almost becoming an exponential bump. It's not just a traditional bump because you're seeing it across each core being able to address much more bandwidth. And so this is actually one of the really exciting things, is where you can really get a nice notable uplift, right? When the applications, of course, are going to be sensitive to that. And so you noted, not every single application is going to be, but that can also, like I said, help to just be offset in general just by the improvement of, that step change, which also, correct me if I'm wrong, but I believe the increase right here, from my recollection, going even from DDR3 to DDR4, and even if we went back to DDR2, but DDR3 to DDR4, and then DDR4 to now DDR5, it's the largest single jump we've ever seen in terms of a memory spec. Generally, it's actually quite a bit more common to almost have a little bit of an overlap in terms of the values, right? Like we saw that with DDR4, DDR3 to DDR4, you actually had almost similar, quote unquote, performance values, right? But with DDR5, it's not even. It's like significantly a much higher envelope.
Yeah. Oh yes, absolutely.
Yeah.
I'm sorry, go ahead.
And I was talking about bus efficiency, like that increase in bus efficiency is also gonna allow higher capacity modules too, which is the other cool thing. I don't think we've mentioned yet, but I mean, 128 gig UDIMMs. Yeah. So I mean, and you're talking about single module performance, like it's, dual channel isn't really a requirement now, which is really cool. So, you might see some laptops with a single DIMM supporting up to 128 gigs in the future. You don't need that extra space for another module. Maybe you're going to have an additional M.2 slot for more SSD capacity or a bigger graphics card in that laptop. So it really kind of opens the door to lots of cool things that we just didn't even think about in the past, because you always needed 2 memory modules, or you're really limited by capacity. And now you probably have as much memory in a laptop as you ever could imagine using. And maybe I'll regret saying that in 10 years, but we'll see.
No, I think that memory point is really good, right? So I think if we take a look, right, I think 16, right, was pretty much our max that we were seeing on DDR4 in terms of what we were seeing traditionally from a single DIMM, right? And now really the big benefit, right, as we're moving now into DDR5 is that just blew up, right? And this gets really interesting again also in some of the potential configurations. There was a little bit touch on 1 DIMM per channel, 2 DIMM per channel kind of configurations, but this is also important because some users in DDR4 that were adopting a 4 DIMM configuration, right? So 2 DIMM per channel setup, might not realize that that's also not necessarily as optimal from your maximum efficiency as, let's say, actually DDR5 is allowing you to effectively have the same or even greater density and only a 2 DIMM configuration, right? So single DIMM per channel. Why is that important though? Is because if you just think about it kind of from a technical perspective, so if I was to, bring over this board here, this is actually just a bare PCB kind of trace layout, and I can put this under the secondary cam, right? But this is where our CPU is. This is where the slots are. We have trace lengths. You literally are having to have more communication because there's more hops. There's literally more signal processing that's involved going to multiple DIMMs than there is to only going to 2 DIMMs, right? And this has already been confirmed by some media in their testing where they're seeing if you actually really kind of want to have that even best performance scenario, you do want to focus in on 2 DIMM configurations. The great thing though is that in the past where that might have been, oh, maybe I'm only going to be able to have an 8 or a 16 gigabyte configuration, right? It's like, well, now you can have, you can have 32, you can have 64 gigabytes, right? Within only 2 DIMMs because of DDR5's kind of design to be able to really be designed for this next generation level of density support for users, right? So why don't you touch a little bit on that? Because I thought that something that I haven't seen a lot of people talk about, and that might get a little bit later into when we talk about maybe some of the things that affect overclocking. This is also part of the reason why there's differences in terms of the overall operating specifications. Because again, from the memory manufacturer side, right? Excuse me, from the CPU manufacturer side, when they're developing the IMC, there has always been, and it will always kind of be, there's going to be a difference between 1 DIMM per channel versus 2 DIMM per channel in terms of the performance expectations, right? More memory is always going to be more complicated, more stressful to run. So you shouldn't ever expect a parity experience, right? But it's still better than it was in the past, regardless. But why don't you touch a little bit on that?
Sure. As you pretty much said everything, the first of all, the jump of memory technology from DDR2 to DDR3, DDR3 to DDR4 is actually not as big as the memory technology transition from DDR4 to DDR5. So that's that. And with the previous memory technology, in order to get the amount of massive bandwidth, users had to overclock their memory modules, the CPU, the motherboards beyond JEDEC specifications in order to get that massive bandwidth. Now, because we have increased the bus efficiency of DDR5, it eliminates or it makes massive bandwidth accessible to more users. So that's one of the key advantages of DDR5. And also touching base in regards to your 2 DIMM or 4 versus 4 DIMM solution. Imagine this. If you imagine a truck and you also imagine it's pulling up a huge trailer on an uphill, it pretty much slows down in order to be able to pull through all that loads. That's how it is for the IMC, the internal memory controller. If users were trying to get bandwidth out of 4 DIMMs installed on a motherboard, and it puts a lot of load on the memory controller, and sometimes it might not give the optimal performance because then you're getting into the scenario of actually your memory actually downclocking it, and because of how the DRAM ecosystem works, the controller is in the CPU and the firmware is in the BIOS is in the motherboard. The DRAM world is entirely dependent on working together with the CPU and motherboard ecosystem partners. And how all of this works is that the memory speed actually gets downclocked. And in order to
so I actually just want to show here a quick reference for people here. So this is actually Intel's formal specification table for reference on current platform, right? For take for instance Z690. So to give a little bit of kind of specificity to what we're noting here, so you can see here we're talking about 4800. So that is going to be, as you can see right here, a slot per channel, DIMMs per channel, and then rank. And you guys can maybe touch a little bit on this to help people understand maybe a little bit on rank and kind of some of these terms that we're throwing. But as you see right here, pretty much effectively is that when you're running that 2 DIMM configuration, right, or that 1 slot per channel, 1 DIMM per channel, right, you can see you have the fastest performance. But then as you move essentially to a more dense configuration, you'll see that that value goes down. Now, I can tell you, at least exciting from a performance perspective, right? This is one of the things that we strive to also work on, and we'll touch a little bit on some of the things that ASUS has done in our memory topology design and through our firmware enhancement and through really kind of close validation design, that we can attempt to kind of give you even higher performance. We can run configurations that actually mirror actually closer to this configuration, even in these configurations, right? But again, we're moving beyond kind of the standard official validated specification. But this is at least giving a little bit of context to understand why there's a difference, right? And this is, as was noted earlier, right, really comes down to the entirety of the platform. It's the CPU, it's the memory controller, it's the trace layout. All these kind of things kind of come together to define the specification.
And to add to that, that's just the memory POR from Intel, right? Specifically for the Alder Lake platform. And then when AMD comes out with their
there will be one that's
AM5
specific for
exactly
them. Yeah.
They'll have their own memory POR. It's just memory POR is independent to each platform that Intel and AMD launches. And one of the cool features that Crucial has enabled to overcome these limitations is that when users are trying to get the optimal performance out of CPUs that may suppress memory speeds at certain loads, memory loads, all they have to do is just go to the BIOS settings and enable the predefined memory profile that we have already loaded, that every single Crucial DDR5 UDIMM or desktop memory ships with. Now, you may have thought, holy moly, I actually bought the first Crucial DDR5 back when it launched. Do I still get this feature, performance recovery feature? Absolutely, yes. We actually put that from the very first module that shipped out our door back in October 27, 2021, when we launched together with Intel's Alder Lake platform. So all this means is that specifically for that channel memory load that you were showing, JJ, like on a 2 SPC, 2 DPC dual rank, the memory POR is 36 mega transfers per second.
Right.
Now, some users might be like, sure, I'm using a workstation, a client workstation with an Alder Lake platform. I actually have to max out my RAM. So I'm installing 4 32 gigabyte modules on my workstation, and the speed might be downclocked to 3600. But as long as they have a good motherboard like ROG's Z690 or ASUS 690 with the DDR5 compatibility, and they have updated to the latest BIOS settings, so good motherboard tier, good BIOS stability, all they have to do is just, they don't have to play with anything else, just enable the predefined memory profile. And that's what we are recovering the performance lost in the process of actually trying to extract more performance out of the memory module.
Yeah, and again, just to kind of maybe make this a little clearer, I mean, with DDR5, this is something new. When we get those, when you're installing multiple DIMMs and the memory controller on the CPU is having to manage that, again, you can see downclock in your DDR5 speed. So what Karthik's talking about is a feature in our modules, basically where you enable that profile and you maintain that performance. So again, this is something different with DDR5. And to people that maybe spend all the money and buy a DDR5 system, and they they fill up all their banks. That may come to a surprise to them, but that's why it happens. But something cool with our memory is, hey, you can get that performance back simply by enabling the profile in your UEFI settings, which is really awesome. So you're really getting all that performance that is on the box, it's on the label, and you're not leaving anything under the table. So something cool to think about.
Absolutely. And just to add a couple of more clarification points about this feature, it's that our Crucial DDR5 are JEDEC compliant modules, meaning these are tuned to JEDEC speeds and timings only. Now, as long as you're just, I'm talking to the users watching this, as long as you're just enabling the predefined memory profile, you're not essentially overclocking beyond JEDEC speeds. So that is something that we do not recommend on Crucial DDR5 because this product is not for overclocking beyond JEDEC. So that's something.
So I think this is a really good point here too, right? Because one of the transitions, right, that we saw with DDR4 to DDR5 was also the implementation of the PMIC, right? And the PMIC is also part of actually performance recovery or overclocking for memory modules, because in the past, right, outside of kind of understanding things like, of course, memory rank, the density, the IC, that can all affect, of course, that voltage was, of course, one of the key characteristics in terms that can influence how much you can push memory. And on the motherboard side, that used to be defined because we would have essentially that functionality was built on board. It was on the hardware side, right? But in DDR5, we've now moved this over directly onto the memory itself. So this is part of the reason also why there's a little bit of an increase in cost to DDR5, because there's technically some more stuff that's literally on the memory that there wasn't on DDR4. But this also does affect some aspects, because some PMICs might be defined specifically for, let's say, a greater extensive performance kind of tuning, right, than a standard kind of maybe JEDEC based focus kit. So can you give a little bit of kind of explanation here to understand the PMIC? Sure. And I'll show you guys a little bit of close up here on the DIMM, but we can also see, if again, you guys can head over to Crucial site, you can kind of see this great little breakdown right here. But we're talking about this little guy right here. It's in the middle of the memory module that you'll see right here. So here, of course, you have your memory, your quote unquote, your chips, right? But this little guy right here, it does affect things. So give us a little bit more kind of information there.
Sure. And before we quickly answer the questions about PMICs, I just wanted to take a quick moment to highlight that Crucial DDR5 is the first in the industry for a JEDEC compliant memory module to provide a performance recovery feature. So I just wanted to say,
I've never seen that before. I can tell you guys as well. When I first saw that, I was like, and traditionally one of the easy ways, right, is, of course, if I was to take out one of the, an older kind of Crucial, maybe in the past, like a ballistics memory kit, right, which would add heat sinks and everything. Normal JEDEC kits look like this, much more streamlined. Although I'll tell you, I love the fact that not like DDR4 where you had the green PCB. I love that. I love that all black PCB.
We made sure that happened. Yes. Yeah, we had lots of discussions like these need to be black moving forward.
I'm very, very, very happy because these they're really clean. They look classy. They look, really nice. And even for, those that might be on the performance oriented side, it just looks good. Even if you don't do something like what I did here, which is I put an aftermarket, heat spreader on there, right? But I like the black. But that is what we're referring to as the JEDEC. Is before you go into there, giving us that, help us just understand technically what you mean by a JEDEC memory kit.
Sure. So JEDEC is basically an association and a consortium of sorts of all the memory vendors, the three original DRAM manufacturers, Samsung, Hynix, and Micron, and also other industry experts coming together, forming an association and deciding on what should the specification of new memory technologies should be. They collaborate and agree on what should be the memory speed, timings. There's a lot of contribution from each companies to be able to say, no, this is what is possible, and we have talked to our users on what they expect from the future generations of memory modules, and they decide what should be the specification. So it's more like a standards association. And
kind of like a Visa take, for instance, right? Where, that's on like on the display side, right? But this is specifically for memory, right? So for those who are kind of just wondering, right? It's a very similar. It's kind of a consortium, a lot of technology leaders that help to define really where we're moving forward specific to memory.
Correct.
And then specific to JEDEC, they make specific speeds, whether we got speeds associated with CAS latencies. So there's standardization and lists for all of those. So when we as manufacturers are producing DIMMs, we make them and sell them to those JEDEC standards. So when you see a 4800, CL40, that's standard across the industry. So and again, it should be plug and play for the most part with some variances to that. So when you see those speeds, you install it out of the box, you should be getting that performance. When you start talking about things like XMP and whatnot, you start getting outside of those industry standards, and there's obviously lots more variable to that, a lot of the details that go into that. But JEDEC just makes sure that there are standardized performance bumps, and you get those with compatible hardware.
Yeah, you're exactly right, Benny.
To that point too, also, right? It's important, right? You noted XMP, two different. So XMP is also kind of like a consortium standard, right? It's defined by a couple of partners. It was originally led by kind of Intel and some others. But this is kind of an important difference, right? So I think when we're talking about JEDEC, this is the industry-wide kind of standard expectation that we really see across platforms, all right? And then when we're talking about XMP, we're talking about a different, right? It's not, it's now kind of, we're moving into another territory where it's
different
not a guarantee, because even if you buy an XMP kit, you can't necessarily guarantee its actual operation.
That is true.
The manufacturer can guarantee that memory has been screened for that performance level, right? But we can tell you on the motherboard side, right? It takes a motherboard, memory kit, and CPU to all work holistically together. And if maybe the memory controller is a bit weak, right, which is variable because now you're asking it to run at a higher level that it wasn't designed inherently for, wasn't validated for, right? You may find that, if you took 10 CPUs, maybe 5 of those CPUs can reach that level, and then maybe the other 5 cannot, right? But at that JEDEC value, all 10 of them can work at that value.
All of them will give you exactly what the manufacturers are talking about. Yes, absolutely. As Benny said, the only 2 features that's very unique to Crucial that you may not find on other JEDEC compliant memory modules on the market are the black PCBs, and the special call out to that, and the performance recovery feature. So you may find other memory modules. Not all memory vendors have transitioned with their DDR4 being green and DDR5 being black. So we were one of the few ones who actually did the transition. So that said, let's go back to the topic that you wanted to talk about, the PMIC. Now, the PMIC, it's the power management integrated chip. For DDR4 memory technology, the PMIC was actually residing on the motherboard. Now with DDR5, the JEDEC Association decided that it would be a much cleaner way to regulate the voltage of the memory modules on the module itself. It's a much neater way of doing it. About 5 volts is supplied to the memory module. However, the PMIC on the memory module regulates it down to 1.1. So 1.1 is the memory or the operating voltage of DDR5 modules. Exactly. That's right up there. And that's the one that has been causing a lot of heartburns for the memory vendors when we came out with this new memory technology.
Yeah, and I think it just makes more sense. I also, instead of having power management, some motherboards that need to be compatible and work with a slew of different memory modules, you're now embedding that on the module, and you're making a PMIC that's designed to work with the speeds and the specs that memory is built out to. So it's awesome that the industry moved that direction. And I think it's going to really just at the end of the day make better memory modules. You're going to see better speeds. They're more reliant. They're going to work out of the box more efficiently than they did before. It's standardizing a lot of the stuff that we didn't have before in the industry, and just going to make a better user experience at the end of the day.
And absolutely. I think that's an important point, right? When we talk about here is that some of these changes have really been, again, kind of designed lockstep with the trajectory of where DDR5 is going, right? So part of the things like the PMIC, with the on-die ECC, which I'd love for you guys to give a little bit of help understanding there too, where there's a difference between outside the memory ECC, and then of course what we're doing here with on-die ECC. So two entirely different things. But DDR5 has a massive trajectory in terms of the envelope, right, that we're seeing from a performance perspective. And even here, impressively on Alder Lake, the scaling that we're seeing, it's greater than I've ever seen in any single generation of memory. It's never been this impressive that I've literally been able to see memory go from 4800 to then 52 to 56 to 6000 and higher so quickly. Before it literally took some generations, right, to scale, and we're seeing such impressive performance envelopes here. But part of that is also, I think, like you noted, the ability to control this more tightly, integrate the consistency of knowing that as a manufacturer, especially for you guys, where you have a high level of vertical integration, right, where you're producing your DRAM, you're helping to produce all those kind of items, right, holistically helps you to kind of really focus in and get great performance, great design. So can you give us a little bit more information on some of these points here, like the on-die ECC and some of those areas?
Absolutely. Now, on-die ECC is happening at the component level, not at the module level. Now, these are non-ECC modules that has this on-die ECC feature at the die level. And what it really means is that if a user were to buy a 32 gigabyte module right now, versus them buying the same module 5 years down the lane, because the technology would become more the manufacturing process and the technology becomes more advanced, the reliability stays the same. That's all it really is about. Because as Benny said earlier, the possibilities or the projections for DDR5 densities and speeds are huge. For example, as the technology matures, we are looking at a possibility of 128 gigabytes on a single stick of RAM, and that RAM is also estimated to work at 8400 or 8800 megatransfers per second.
That's just insane.
I know, right?
And we're not talking about server memory either. This is UDIMMs, laptop,
client.
and your client.
Exactly. Non-ECC, UDIMMs, and SODIMMs. Now, when you get to those higher densities and speeds, reliability is a huge concern for memory vendors. Now, it doesn't matter if you're promising higher speeds and densities if you cannot guarantee reliability. So when we get to those points, memory vendors have to be able to provide reliable memory, and on-die ECC makes that possible. So on-die ECC is also one of the reasons why the number of clock cycles, our CAS latency, is 40 on DDR5. That's a fun fact, so I just wanted to throw that out there. Now, another frequently asked question in our online community is, why doesn't Crucial DDR5 have a heatsink? This is one of the questions that have been asked multiple times. We have done our thermal analysis and study for a JEDEC compliant DDR4 4800 CL40 modules. We do not see a need for heatsink. Now, we continue to study this. It remains to be seen whether our future DDR5 products needs heatsinks or not, but at this time we do not see a need, as long as you're only enabling these modules to perform at JEDEC speeds and timings.
Yeah, and the other cool thing too is with the current memory modules too, because of just a lot of improvements in terms of the way that the components are being designed here too, is there's a lot of actually telemetry that's provided that wasn't always provided in DDR4. So users that even do want to have access to that information, they can load up the utility either on the motherboard side, and they can actually check that. They can see the actual thermal information for the memory, which is pretty cool. This wasn't historically before. You almost had to buy like a memory module that specifically had telemetry information to be provided to you for the actual thermals for the memory. So it's cool that maybe you're one of those guys. Maybe you want to buy your kit. Maybe you want to try to take it a little bit further. You want to get a little bit more information. There is merit, when you go beyond JEDEC standard, that if you can have things run cooler, it can help to sometimes maximize some headroom, right? Just like it is for a CPU, right? The cooler that you can generally have it, the better, right? But I can definitely tell you, I've run extended heavy workloads on 64 gigabyte, 120 gigabyte configurations, an hour full decompression workload where I'm expanding, 20 gig you know, 40 gig files back and forth and swapping across the memory, and it doesn't even break a sweat. It's like, it's literally, it's not a problem. So that's the great thing is that, yeah, if you're running just, you know, your stock expectation, you know, in terms of your standard profiles, you can feel comfortable and confident. You don't have to have any concerns in terms of that heat sink. And again, if it's a real big factor and you just want it for aesthetics, again, just like we've done here with our Crucial, I think this is the 16 gigabyte kit, you can get an aftermarket heatsink if you want to add it, right? But, you know, they got a very nice black PCB, so you don't got to worry. And I think it was great. You talked a bit about, of course, what we're seeing in terms of the scaling opportunity, right? So this is going to be another thing, right? Whereas we're moving into, you know, next generation platforms, next generation memory controllers, right? The speeds are only going to increase. You know, this might get into a little bit at the end when we get maybe some popping questions, but I think maybe a good point here. You know, we've talked a little bit about kind of speeds, so maybe it'd be good to just give us some clarification between that. You know, we're finally seeing the transition to correctly kind of define memory in terms of mega transfers as opposed to megahertz. So can you give us just a little bit of kind of that breakdown on when we're talking about memory, help us understand that megahertz as opposed to mega transfers, right? Because memory, we should be defining it, right, as like, you know, 3600 MT, you know, 4800 MT,
Yep,
you know, as opposed to megahertz, right? Because they're two different measurements. They're not the same thing. They're different things. Yeah. So can you give us a little information there?
Sure. So for example, our Crucial DDR5, the one that we have in production and being sold at this time, delivers about 4800 mega transfers per second. Now it because this is dual data rate technology, DDR, there's actually transfer both on the up cycle and the down cycle. So your megahertz is half of your mega transfers. So it's about 2400 megahertz, but mega transfers is actually 4800. Now we know that in the wider industry, pretty much anyone selling PC components have gotten used to the term megahertz. So both are acceptable as long as they understand what they're talking about. But we've been kind of okay with both units as long as they understand the difference.
Right. But technically, right, you know, if we want to try to define it correctly, we should be using mega transfers, right? So MT, right? Or some people, if you prefer, just don't put anything. Just
don't put anything.
Just put the number, leave it as a number.
Just exactly. You can just say DDR5 4800 and everyone will understand.
Yeah. So for reference here, we're at your guys' web shop, and you guys can see right here when you have the list
exactly.
You'll see right there. It doesn't even have MT, so you don't need to worry.
We don't even have that.
Yeah, you've got the information just clearly noted for you right there. But for those that are wondering, right, when you open up utilities, so if you open up something like CPU-Z, right, that's the reason why you would still need to go to the actual, you'd see the value and you would have to multiply it by 2. Some other utilities like ADA64 or HW Info actually will show you the effective cycle, so you'll actually see the correct quote unquote value that you're looking for. So it just depends sometimes on the utility you're looking for. In the UEFI, we also give you the effective value. So in the UEFI BIOS, we give you that, so you don't have to do the multiplication in your head, right? But we just want to go ahead and clarify that. So you already did a great job in terms of giving us a little bit of that last kind of, I think, point there that I thought was important in terms of kind of what we can expect for the future. But just overall, you know, even though we're just starting, right now, what do you think you're most excited about? I mean, I think the fact that already you talked about the speed along with the density, for me, I think are some of the most exciting aspects. I mean, even right now, the ability to be able to run, you know, 64 gigabyte configurations, right, at these high values, which were really unprecedented, right? When you talk about DDR4, even these higher performing kits of memory that were out there, they were generally reserved for much lower density configurations. So you were talking about, you know, even 8 gigabytes, so 2x4, or, you know, 16, and maybe at the end you were starting to get into 32. But as always, right, as you scale in terms of the memory density, right, you're going from single rank to dual rank, you're going to generally be bringing things down. So it's really exciting to be able to see that, again, we're still dealing with those same realistic limitations, right, where as we get up, right, we're bringing things down, but we are inherently seeing a big bump up, I think, regardless to either kind of configuration. So if you're going to go for that less dense configuration, you're going to get really, really amazing speeds. And even if you're going into these very, very dense configurations, you can still see really impressive things. So that's, for me, I think what I'm most excited about. But from your guys' perspective, you know, is it just that combination, or are there anything else?
Yeah, like for me, it really it's kind of like the whole ecosystem. I'm really excited to see where applications, where the operating systems, where all the software takes this increased performance. Because at the end of the day, performance is great, but you're really always going to be limited by how fast your application is or how well it's coded to take advantage of that. So basically, we as hardware manufacturers have created something awesome here, and we're letting all those developers out in the world now take advantage of it. And again, as a gamer, I'm really excited to see where Microsoft's going to do that, because for a long time we've always been limited by what an OS can do and what basically advantage. There are limits. You could install 128 gigs of RAM, and that wouldn't give you any more gaming performance than, say, 16, maybe even 8 would, and like CSGO, CSGO is like 8 gigs of RAM, 16, so really a lot of those things being developed in the future. That's what I'm really excited for. Also really excited about the next sentence. So I'm doing a new build for that. So yeah.
Benny hit the nail on the head. Absolutely. And what I'm really excited about the future of DDR5 is that, let's say there are users who would love to buy or build a client workstation system like a Threadripper Pro 5000 series, right? And then a 5950 or 1550X or whatever. And what they can do is, and let's say they have an octa channel motherboard, and the maximum density what they can take up right now is 8 32 gigabyte densities right now with DDR5, and the future possibilities are up to a terabyte of RAM, because 8 128 gigabyte modules. Imagine the amount of high performance computing at a client workstation that can perform for the next gen Threadripper Pro that would enable DDR5. So that's all the exciting possibilities. The amount of computing power, the next generation of CPUs, motherboards, and memory modules would be able to provide to users, to client consumers, which was not previously possible. That's the key thing. With the previous memory technology, all of the whole ecosystem was not able to provide this level of performance. Now, and
we've been needing it. I mean, that's the really cool thing too here, right? Is we've talked about just some of the consumer side, right? But take for instance, we also have a server and workstation division. We work on deploying real big installations, right? And when you talk about like cloud infrastructure and actual how that also affects the consumer, there's back-end experiences because of us essentially having so much faster memory. That's going to also continue to improve the experiences that many of us don't realize are being affected by things like the next generation of PCIe storage devices, the next generation of DDR5 memory, right, which allows those platforms that are pushing things out to you to be faster, right, and more effective, right? So that's the really cool thing too, right, is that we're getting to realize this DDR5 really across the entirety of the industry, right? Not just forward facing as a consumer, but the consumer is actually getting in two different ways, right? Ways that they don't even realize, and ways that they're also seeing it directly on. So really exciting.
Now, although I do want to quickly highlight just one other thing. Now, for some users who might be thinking, well, I'm going to wait until those awesome speeds and densities become available. Sure, that's absolutely fine. But for those users who might be on the fence thinking, should I consider transitioning to DDR5 or wait? The answer is it entirely depends on whether you have invested in the next generation platform or not. If you have invested on the mobile side for a Ryzen 6000 series based notebooks or laptops, or on the desktop side, you have already invested in a 12th gen Intel Core CPUs, then DDR5 may be a good option for you if you're looking for bandwidth and you have bandwidth intensive or sensitive applications and workflows, because you get that memory bandwidth, which if you adopt DDR4, you might not be utilizing your CPU's full potential.
So you're going to be leaving some stuff. Yeah, especially if you're pushing into these high core count configurations, you are literally going to be leaving performance on the floor, right? It's literally just it's not going to be fully realized because it was inherently designed to maximize the performance with that technology, right? It's similar to when, Intel developed the Alder Lake IPC and architecture, right? They were able to best optimize its performance with Windows 11 because it required some, deep kernel-based optimization for the things like their thread director and other things like that. So you had to consider, okay, I'm fine with Windows 10, but maybe I'm going to be losing a little bit if I don't also consider going over to Windows 11, right? And so this is a similar type of experience that you're not necessarily affording yourself. And similarly, that we're in the past where maybe you had an older platform and you could take that older memory and maybe transition it over, even if it wasn't the same speed that might have been supported for that platform. The other nice thing too is that DDR5 is only what we're going to be using as we move forward, right? And so the great thing is here is that if maybe you're right now on Z690, but then into Intel's next generation Raptor Lake, which they've already announced, it's a DDR5 platform as well, right? You're going to be able to take your DDR5 kit and move it over to Raptor Lake, right? So it's not so, as always, you guys made a great point. It just comes down to what you're looking for. But I think the great thing is that now, especially with the pricing stabilized, I think it's actually quite competitive. On average, you're talking generally, I would say, depends, of course, on the density, right? But if you guys look at something like your 4800 MT kit, right, 16 or 32, your delta's in the range of about probably $75 to, I think, about $100 delta, which is really not that much when you also consider, like I said, you're getting actually a performance uplift, especially if you're comparing that to the standard stock, where if you're adopting into something like a 3200 MT, CL20, CL2022 kit. And a lot of people like to sometimes go to lower values. But again, if you talk about what's the broad majority of the kits that are sold on the market, they are going to be in that higher value, right?
Absolutely.
The delta of cost really is actually not that much. And again, you get that performance uplift, right? So that's at least the way I see it.
You're absolutely right. If you buy an Alder Lake desktop CPU, right, you adopt as a Z690, but a DDR4 version of the motherboard, and you adopt a DDR4 memory module right now, thinking you will consider transitioning to DDR5 later when the prices get better. Well, sure, that may work in your favor right now, but when you're transitioning to DDR5 memory, you actually have to replace Z690, but the DDR5 pin compatible motherboard. So you anyway have to switch your motherboard. So it may be a good option, financial option, that the prices varies by region and with time. So you may want to bookmark all these products on ASUS website and Crucial website. We're also actually running a cross promo, which has been live this summer. So if you were to buy a product on ASUS website, you're getting a coupon code by coming to crucial.com. And likewise, if you buy a product on Crucial, you're getting a coupon code to buy products on ASUS. So bookmark these product pages, so you would get awesome deals, and the prices as JJ has mentioned, it has substantially decreased compared to how when we priced our products when we first launched DDR5. So suffice it to say, it all depends, as JJ said, what are your needs. If you are looking for you are a data heavy user, you're creating content out there, or gaming, or doing some engineering activities, and you work with a lot of data and you multitask a lot, you need performance, and that's when you're going to adopt multi-threaded performance, which is great with these next generation of CPUs. And when you adopt this, you will have to adopt. You're better off by considering or adopting a Z690 motherboard, ROG or ASUS, and with a DDR5 compatible board and a DDR5 module from Crucial, you would get the best performance for your bandwidth-sensitive applications and workflows. Now, if you adopt DDR4, as I said, you anyway have to change the motherboard later on. And as JJ said, you can still just adopt the newer platform when the Raptor Lake launches. You can still carry forward what you have bought now for the future platforms, but DDR5 is not backwards compatible with DDR4 motherboards. As one of my colleagues would joke, anything is possible with a hammer, so don't try to install DDR5 module on a DDR4 motherboard, but please don't. You're going to break something. And
I don't want to touch on that, right? So again, we didn't touch on it because it's a very basic thing, but it's important to note. We can get a close-up shot, but some people call it the notch, but I believe technically it's called the module key. Is that the module key, that little area right there on the bottom side. So if we took a DDR4 to a DDR5, the module keys are different, right? So even though the physical, right, the length of the memory itself is effectively the same, right? They're going to look almost identical if you overlap them, right? The module key itself is not in the same location. So you know, at least that's good, right? That you can't kind of mess it up.
If you
I have seen people kind of force memory, but it is important. You cannot take a DDR5 stick and put it on a DDR4 board and vice versa. It doesn't go the way around. It needs to be specific to the platform.
Exactly. And one other key call out, some people might be looking at some information online. Oh, well, DDR4 UDIMM has the same number of pin count as a DDR5 UDIMM. Both are 288 pins.
Yeah.
Well, the pin assignments are different, as JJ said. The module key is at a different location. So when you're trying to install a DDR5 module in a DDR4 motherboard, you will feel that resistance. So don't
do that teeter-totter.
Exactly.
Back and forth,
exactly. And on the SODIMM side, or the laptop memory, it's much more easier because it's 260 pins for DDR4 SODIMMs, but 262 pins for exactly the little gold pins at the bottom. It's 262 pins for DDR5 SODIMMs. So obviously there are pin differences on the SODIMM side. On the UDIMM side, the number of pins being the same for DDR4 versus DDR5, it's just a pure coincidence. The pin assignments are totally different. The module key or the notch positions are different. So please make sure when you're buying either the platform first, the CPU or the motherboard first, you buy the compatible memory, or if you bought the memory first, please make sure you're buying the compatible motherboard. And if you were to come to crucial.com/DDR5, if you want to start with the memory and then go work backwards with CPU and motherboards, our website helps you identify which are the exact DDR5 compatible motherboards from ROG and ASUS. And we'll be more than happy to help you, because we also have a world-class technical support team to be able to answer all of these questions.
Yeah, and you guys, of course, also continue. I mean, you were, I think, one of really the first, and a lot of people would always use it, right, is your guys' great upgrade tool, right, where you can go in and you can plug in your information so that you can know that. That's a really great also option, again, where a lot of what we've talked about is, I think, has been first and more focused for the PC DIY and our motherboard users, right? But of course, this is applicable, of course, also for laptops. As I said, both now we have rolled out AMD and Intel-based laptop solutions that are utilizing DDR5. We're right now shipping out our first generation of mini PCs, which are also equipped with DDR5 SODIMM. And so it's great that you guys have the flexibility that you offer memory solutions that users can go into the site, be able to plug in, know that, hey, this is going to be drop-in compatible. I can put it in and get a great, stable, and reliable experience. And then, of course, if you have any issues, you guys have great service support. So, you know, you guys could reach out to them, make sure that everything is, you know, covered on that side, right?
Yeah, and I think that's a great topic about compatibility, because there's always a misconception I've seen. With DDR5, it's so fresh. It's not as true with previous generations. But when people are looking at a motherboard and they're looking at the vendor's list of compatible memory, they often go and look, well, oh, my memory isn't on there. It's not compatible. Well, a lot of things people need to understand with those vendors lists is they often make them at the time they're qualifying those boards.
Yep, correct.
True.
So
Very true.
Those compatibility lists are only good for as long as when they did that qualifying.
Exactly.
So they
until
often
they get updated. Yep.
Yeah,
exactly.
And you know, whatever you have dozens and dozens of SKUs of motherboards. You're not going to go back and qual all those individual motherboards and add every new memory module that comes out in the future. It just doesn't happen in the industry. So cool thing about our website, if you search whatever brand of motherboard you have, model number, you can search on it. We actually go in through and we're updating those constantly. So we have a team that's dedicated for all those boards. So I mean, we have tens of thousands of different boards and systems on our website. We go back and we update them for our new modules and new motherboard SKUs that come in. We're continuously doing that. So a lot of people, especially watching this video, you know what memory is compatible. You know DDR4, you know what the limits in your motherboard are. But for people that are kind of on the wall, you know, maybe they're using PC part picker and they want to double check, just hop on our website, throw your motherboard model number, and and we make that easy for you. We show everything, including SSDs, which will work and be compatible with that board.
You're absolutely right. And thank you, JJ, for bringing up a quick call out for our tools. These two tools, Crucial System Scanner and Crucial
System
part
selector,
system selector. Both
it's
are
both the same thing,
right,
yeah.
right, exactly. But the system scanner is more for users who have bought an OEM system like from Dell or Lenovo or HP, and they want to upgrade their memory. And I see the system advisor tool is more like for DIYers, users who are trying to build their own system, but they want to make sure compatible.
I don't need to run the scanner. I know my motherboard model number. I just want to search it up. Or
we see users that use them both. I mean, even on, like I said, our desktop, we actually, you know, because we do have a lot of users. I mean, even for us, we've talked about our ROG, but, you know, we have multiple series. We have everything from, you know, our Prime series here, which are kind of more designed for our general users and kind of professionals or content creators. We have our ProArt, we have our workstation series, and then we have gaming product like our Tough Gaming and ROG series. And it really depends. We have some users that are stepping into it for the first time. So I think it's giving them more confidence and a more comfortable experience to know that they can go to that site. They can download an easy to use tool, scans their system, and lets you know, pops up with the page, hey, you know what? You can go ahead and drop in, you know, a nice Crucial, you know, M.2 based SSD if you want one, right? You can also drop in, you know, some nice, you know, 16 or 32 gigabyte kit and make that experience just much more seamless, right? So regardless of wherever you are in the customer journey or kind of in your experience, whether you're buying a laptop, mini PC or desktop, you know, it just makes it simpler, right? Just makes it easier experience.
Definitely.
These two tools are legendary, whether you're upgrading your memory for an OEM system or building your own system and you're new to the PC building world and you're exploring all of this. We have tools to help you out. We have a ton of resources on our website, how to videos, articles, and whatnot. We have installation guides on our website. We have a ton of resources online. If you have any questions, you're more than welcome to reach out to us or visit our website.
So I think from there, I just want to go ahead and add a little bit here. You guys have done, I think, a really great job to be able to give us a really good foundation, I think, at understanding, you know, what DDR5 is, right? What are the key improvements, how we've seen benefits in terms of it from complementary to the kind of the development of, I think, the current state of technology when it comes to PC platforms and CPUs, right? Where they're kind of lockstep at really being able to maximize each other. We've also talked about, I think, improvements in terms of what we're seeing for the future in terms of density and performance, right? So overall, I think we've got a really nice foundation to hopefully give you guys a better understanding of hopefully how DDR5 affects you and how it benefits you and how it can provide you, I think, a better experience when it comes to, you know, performance, to overall usability, right, and your overall kind of platform, right, because memory is really such a key part of the experience when we're using our system. So on our side from, you know, a motherboard manufacturer, I just want to touch on some of the things that we do to hopefully be in alignment, I think, with a great partner like Crucial and Micron here, as well as, you know, how do we hopefully help to make the experience maybe a little bit easier for you in a couple of ways. So, you know, first and foremost, we've already talked about this a little bit, but is going to be our commitment in terms of R&D and validation. You know, so we are the world's largest motherboard manufacturer. You know, I think the last metric is we're, you know, somewhere over 555 million motherboards, right? It's an insane number of motherboards that have been sold. But what I'm actually most excited about is I look at things like our, take for instance, like our validation table, right? We're the number one motherboard manufacturer that's validated at, let's say, Intel's XMP laboratory. And so we've held that for both DDR4 and now also hold it for DDR5 as the number one motherboard platform choice for validation. So what that ultimately just means is that you can have a more comfortable and confident experience that if you're going to buy anything from an ROG board to a Prime board to a WS board to a Pro board, you can feel confident that really kind of the industry players like Crucial, like Intel, like AMD have our boards in hand and are helping to validate and make sure that it's going to be a great experience, right? I think that's a very important part, right, at that highest level. There are also things that we do in terms of just continued validation over time. So, you know, Benny, you made a great point in terms of QVL, and we actually do update, but more critically, and I think more important, is also that we have really an expansive team of R&D and engineers on the firmware side, because when we're designing and developing the boards, it's not just about the PCB and the trace layout, which are all very critical, but an equal part that's very, very important is the memory tuning. So the MRC, the memory code, and a lot of things that we can do to optimize specific to our board. And this will vary from board manufacturer to board manufacturer, their topology and their tuning to be able to maximize the experience. And we have really kind of maintained that leadership position to do a lot of work there to really make sure that we can give users confidence that as you can update that UEFI, we are making kind of continual efforts to try to give you the best experience possible. So I can tell you, like originally on, right, 4 DIMM configurations, right, when you're running 2 DIMM per channel, you know, it was going to be much more realistic. Even at launch, we were already breaking the standard, which was 3600, right, which I think was the max configuration. But we were already doing greater than that. We could see, you know, 4000 MT, right? But now I can actually run, you know, I can take your guys's actually kit. And again, this is working outside of the standard expectation envelope, so it's not a guarantee, but I can enable that XMP profile that's on your guys's kit, and I can run a 4800 MT 2 DIMM per channel configuration. That's 128 gigabytes running at 4800 MT. So that to me is just mind-boggling that I can literally drop in, 4 DIMMs, right, and be able to achieve that. And that's been, you know, a pretty recent update, especially with our 1400, 1500 series UEFI releases that we have for all of our Z690 series. So it's not just the high end. Again, we could go down to something like our Z690-A board, our most entry board, and you can get that same comparable experience. So that is also something that, you know, we've worked at really, really hard at. Now, one of the other cool things that I actually want to show you guys, and I don't know if you guys have seen this, but we actually implemented this actually in the DDR4 era, but I think it became even actually cooler within the DDR5 era, is that we integrated passmark UEFI memory testing into our UEFI BIOS. So one of the most kind of common things that a lot of people are always kind of wondering about is like, is my memory okay, right? Like I install it and I want to figure out is it stable? Is it reliable? Is it working the way it's supposed to? So here I can actually show you guys a little quick demo of how this looks. It's very easy to be able to benefit from, but we offer it on our ROG class boards where you can pretty much just boot into UEFI. You can check your memory, but then if you want to boot into actually your memory test, you can do that. So let's go ahead.
Awesome. Go for it.
Go here to our little setup. So let me go ahead and adjust my keyboard and mouse here. And we're going to go into our UEFI environment. So I'm just going to go ahead and reboot here. And I'm going to go ahead and hit that delete key so that we can go ahead and enter into the UEFI environment. But one of really, I think the big benefits that we have in terms of this is it just makes it more streamlined. Because in the past, right, if you wanted to do a memory test, you would have to download a bootable utility. You can get an open source one like from the MemTest group, or you could go to Passmark and you could purchase it. And that has actually some additional kind of tools in there, right? But you would still have to go and you'd have to make a bootable USB flash drive, and then you would boot into this. So this we felt is an easier experience for the user. So you can see here, I've gone ahead and now entered into our UEFI environment. Now we're in our advanced mode environment, but if we head over to our easy mode interface, of course, we give you a nice little readout of all the information. So you can see right there your DRAM status. It tells you exactly that that's a Crucial 16 gigabyte kit. We do have the older value there, the megahertz, right? So important, keep in mind that there is that difference where ideally we will be actually updating this to MT-based value in the future. And then we also have the effective value information. But from there, if you then actually want to go and let's say enable that XMP, which is great to be able to offer here on this kit, we can go and we can click on that. And we can then see that it automatically loads that. So really, really simple to be able to just do that in that easy mode environment. And then from there, if let's say I wanted to go and then test my memory, you can see there's a nice little button that says MemTest 86. I can go ahead and click that. Yes, and you'll see that it reboots directly into the actual MemTest interface. So we can test the memory and verify that it's working correctly. It has actually a little bandwidth chart in there, which is really cool too. You can actually even store the information. So that's really nice. So a lot of nice useful information. So there, of course, it would run. I can go ahead and exit out. I can end the current test, right? To end the test, you can see complete there, right? It would give you a pass, right, if it actually completed, which is really nice. And then you can actually see the little readout of that information. And then you even have right here, which is cool, you can see things like you can have a RAM benchmark and you can actually store that information. So you could have a nice little readout all within there without even having to get into the operating system, right? So we think that that's a nice value add that's available. In addition to that, we also maintain what is called our SPD tool. The SPD tool is a nice, easy way that if you wanted to actually get more advanced readout information for the memory, you can actually go into the UEFI environment and access the SPD tool to be able to read all of the relevant information for your DRAM. And because we also offer a screenshot function inside of the UEFI environment, you can attach a flash drive and you can go ahead and save a flash drive. You don't have to take a picture with your phone. You can just store a screenshot. So an example of that is if we head over here to our tools, we can go over to the SPD information. And you can see right there, we give you all of that readout information. It's all broken down, literally the part number, the serial number, all the value tables. It's all broken down to you really, really easily so that you can have all your information at hand. So we think that that's also another way that we help to really just improve the overall end user experience. So let me go ahead and just make sure my XMP is enabled there. I'm going to go boot back into the OS and show you guys one mother value here. So we'll do that.
JJ, I will say I've always appreciated ASUS's UI and their UEFI. Always very easy to navigate and find things I need. After working with a lot of OEMs, custom-built UEFIs, like it's when you go to ASUS and you use a quality UEFI and screen to find everything, it's, oh my God, it's like,
yeah, I wish
definitely every vendor could have the same quality as you guys do.
It's challenging. You know, I was there when we actually transitioned from legacy to UEFI, and you know, everything from just getting UI cursor acceleration to menu layout functionality to so many things. It's been an undertaking, but you know, we've been really happy to be able to really kind of be I feel, the industry recognized leader at the kind of the quality and the experience of our UEFI environment, and it takes a lot of effort. And we're actually excited about the next generation that we're going to be introducing in the not too distant future to overhaul and even bring in some new features in there. Some last things that I want to touch on here, and maybe you guys can also help to give us a little bit of details because were some updates, right? But of course, we talked about XMP right there. We talked about these JDEC modules having that XMP support. But just to give a little bit of context, right? We do officially support XMP in our UEFI environment. That's what we showed you. You can toggle into it if the memory module has it available to you. We also have full support in our firmware for Intel XTU, right, which is Intel's utility, which will allow you to actually make adjustments to the memory dynamically within the operating system environment. Now, a lot of users don't consciously think about doing this, but it's actually a much more sensible way to do performance tuning because you don't have to go through all these reboots, and you can actually see changes dynamically right there in real time in the OS. So yes, you may, if you're performance tuning, you may still go risk get your crashes and whatnot, but having the ability to be able to kind of access that information directly there within the OS environment is cool. But I want to just give you guys an opportunity there. If you could give us a little bit of perspective to understand some of the benefit of going over from XMP2 to now XMP3, because DDR5 brought in a new XMP standard. And what are some of the things we can benefit from here? Because I think some of the things are going to be, of course, applicable to the desktop side, but there is some actually cool stuff, especially with actually the dynamic clocking technology that actually is going to be a little bit maybe potentially applicable on the laptop side. But if you can at least just give us a base foundation of a little bit of that difference.
Sure. XMP 2.0 is Intel's technology for enabling overclocking or extreme memory profiles for DDR4 technology. So for DDR5, they saw a need to improve and adopt the technology for working with DDR5 modules. So that's XMP 3.0 in a nutshell. And as you said, the dynamic performance tuning is also a really cool feature. As you said, you don't really have to do all of this in the BIOS settings or restarting it. And one of the other frequently asked questions is with Intel's Alder Lake platform is the dynamic clocking feature that they have introduced. I think it would work synchronously with our XMP enabled Crucial DDR5 flawlessly because especially when you're installing like 4 DIMMs, like 432s, all trying to clock at 4800s, and you're recovering the performance. That feature from Intel's Alder Lake platform with our XMP enablement and validated on ASUS's motherboards will all work together seamlessly for a good customer experience to be able to recover all that performance back. Anything that you would like to add, Benny?
Yeah, I mean, I guess I think one of the cool things is with XMP 3.0, in the past, there's lots. I think JJ mentioned like, hey, you would see these XMP speeds on a kit of memory, but there was lots of variables to make sure you would actually get that when you install it in your system. I think moving forward with 3.0, a lot of those variances are going to go away. And for most users, it's going to be a more streamlined experience of actually getting those speeds that they saw on the box and whatnot. So I think that's cool. Just everything with DDR5, we're raising the bar. So it's basically we're getting a lot of those performance and specs that we got only out of the highest tier, highest bin kits of memory in the past. And again, those are all standard now. So it just makes it a very level playing field for especially a lot of new and entry level people coming into PC building and gaming and whatnot. Hey, you can get a lot of this awesome performance and you don't need to go in and do a lot of the nitty gritty stuff you had to in the past in order to maintain that and get that. So it's just cool. I'm excited for it. I think this is the right direction the industry is moving. So it's cool that we're going there.
Absolutely. And to just add more to the same topic, now this is just Intel-based platform technologies that we're talking about. When AMD comes with their AM5s and 4,
Yeah, we'll have Expo.
Exactly, Expo. We will once again, as Benny and JJ were talking to, we have stringent pre-market validation and testing protocols that we all work very closely with each other. We work with our US teams, our Taiwan teams, to make sure both the memory and the boards and the chipsets, the CPUs, they all work with each other flawlessly. We'll make sure to enable all of these new and awesome features the new platforms enable to work flawlessly with our motherboards and memory products.
Very cool. So one other thing that I think is pretty cool here as we get ready to kind of wrap things up is going to be, I wanted to touch a little bit on just one of the physical aspects too that we have on the motherboard side. So as we take a little bit of a closer look here, this is actually our Prime Series Z690 series motherboard. Some just basic things that we've tried to do to also make the experience a little bit easier when you're installing the memory. So we also were the first to pretty much implement this, what we call single latch design, so our QDIMM design. So historically for most actually installation of memory, you generally are going to have two latches. But part of the reason why we did remove one of the actual latches is that because when you usually have a graphics card, sometimes actually removing or accessing this secondary latch can be a little bit more problematic. So that was one of the reasons why we went ahead and did away with that secondary latch, is to just make the installation process a little bit more streamlined. Another thing too is actually having silk screen to the PCB, where some people do not realize this, but if you actually take a look there at the PCB, you'll see that you have the actual channels that are listed, but there's actually a 1 that denotes actually the primary or the prioritized channel. And that's important because actually one channel will actually have a signal path optimization. And actually the trace layout is more tuned for that actual channel. That is for, standard kind of, JDEC level kind of memory, it's not a concern, right? You could go in either war. The board supports auto banking, so technically it would work. But when you are going to be running higher performing kits, then you would generally want to use the prioritized value. That's going to always give you that best possibility to be able to get that experience from there. So that is another kind of way that we've looked to be able to improve upon the experience. So just a few things to hopefully be able, I think, align with all the great information that we've gotten from Crucial and Micron. And I think one of the last things, and it's very kind of complementary to what we've talked about, at us kind of doing all this design development, and we touched about a little bit earlier, but I think is a really important point for you guys is that, we've talked a little bit about saying Crucial and Micron, right? And some people kind of like, are they the same? Are they not the same? But for me, one of the most exciting reasons why we also reached out to you guys is that you guys have a unique place actually within the industry. I think, to a large degree is a very kind of impressive vertical level of integration that not many memory manufacturers really can say that they have, right? You guys have a massive, IP history in terms of your patent history and kind of DRAM leadership. So why don't you guys just give us a little bit of perspective on that?
Yeah, so it's really cool because when you look, you say Crucial by Micron. I mean, we are Micron. We are Micron employees. We work for the Micron company. Crucial is just our consumer brand of products. So Micron products are in your everyday. They're in your phones. They're in your automobiles. Like they're in your servers. Micron's making memory technology that drives the world. But of course, you can't just drive up to a Micron factory and buy some of their DRAM. So that's where Crucial comes in. So we are the brand that consumers use to upgrade their small businesses, your gaming rigs, your laptops. We essentially, so we're that part of the Micron business where we're providing solutions for everyday users. And the benefit of that is being part of Micron. We are what we call in the industry vertically integrated. So we are streamlined, connected through all that. Those Micron processes, which is some of the basically leading R&D and development in the world. So when Micron is talking to Intel and AMD to validate memory for the next gen CPU, we are part of that process. So when you buy a Crucial product, you're getting all of that validation and all that testing that went into the back end of Micron. And it's cool because I get to say we make our memory. We look at competitors, they're often using Micron ICs that we manufactured and made. So it's cool to be in a position where I can say, we make our memory, we make our SSDs. They're our products from start to finish. So, and it's cool. It's something awesome. And that speaks for the quality of our products. And again, a lot of it has to play into that vertical integration.
Absolutely.
Yeah, I think the historical confidence is important there too, right? I think that vertical integration is part of the reason why so many people feel such a high level of confidence when they adopt into the Crucial product portfolio, right? And also industry-wide, when you talk about Micron, right, and its integration, as you noted, literally everything from smartphones that are using LPDDR, right, to then even GDDR6, HBM, right? I mean, there's storage enterprise solutions, 2.2. I mean, it expands, such a great range of different types of technologies and different types of solutions. But that real tight vertical integration allows you to guys really be at that forefront. And so that's one of the great reasons, like you said, you can get that Crucial product and you can know that even back when this product was just starting to get into labs at wherever it was, whether it was Intel's labs or whether it was AMD's labs, wherever those labs might have been, there was Micron right there at the kind of the very beginning, right?
Absolutely. And just to add to what Benny said, Micron has been there in the semiconductor industry for over 43 plus years. And our core competency is nothing but memory and storage. And
That's
Crucial, exactly. and Crucial, being the consumer brand of Micron, we have had 25 plus years of experience developing consumer memory and storage products, which are for gaming or home use or office use. Consumers can come to our website, or we also have an awesome distribution network through which customers can buy. We also have products available at Amazon, Newegg, B&H, Adorama, and etc. and whatnot.
Yeah. So I think that overall wraps up a pretty big deep dive here into DDR5. How I think it's like, again, it is really going to be it's not even the next, right? Because it's right now. The great thing is that we've talked about something that you can literally go out and you can buy, right? You can get a B660, you can get a Z690 in the not too distant future. You're going to be able to adopt into AM5, which will have it. You can get laptops both on Intel and AMD side, whether it's our G14 or whether it's our ZenBook, S13 OLED. They're featuring DDR5, our new PN52 DDR5. So this is a great thing is that this is right now available and it's only going to get that much better. And Crucial is going to be a great source for you to be able to upgrade into your DDR5 as well as your storage solutions. We didn't touch on it too much, but I know you guys have a great lineup of different products with your P3 and your P5 series, right? I think what P3 goes up to something like 4 terabytes, right? I think the P5 is maybe a little bit less in terms of the density, right? But if you're looking to adopt into PCI Gen 4, which is that latest generation standard, right, to be able to complement your high-speed memory, that's going to be a really great choice so that you can tie that in together. And I know, Benny, you talked about Windows 11 with things like direct storage coming on. That's going to be a great thing to be able to kind of complement that and be able to give you a great experience when it comes to responsiveness and a better gaming experience. So all the way around, hopefully you guys have found this interesting and useful. If you have any questions, comments, feedback, feel free to go ahead and drop them in the chat section there, and we'll do our best to go ahead and follow up with you guys when we can. We also have a link to our ASUS PC DIY group, which it's an amazing community of ASUS enthusiasts from all throughout the world that if you have interested and figuring out, what's going to be the right choice for your system, what you want to build around, whether it's going to be small form factor, whether it's going to be a large water-cooled system, whether you're building for Adobe Photoshop or whether you're building for, the next update patch for Cyberpunk. Join us in the community there and we'll get you covered. And also, like we talked about, if you have any questions regarding DRAM or memory and where to upgrade, you guys can check out, of course, Crucial's website. Use that great, of course, assist tool that they have there to be able to figure out what you can drop into your system, and you're going to be good to go in that respect. You guys have anything that you want to plug out before we wrap things out here?
No, I think you hit everything quite well. So just really quick back on the storage front, I think when Gen 5 comes out, we may have to talk again. So we'll get some guys from the SSD side. So
yeah, definitely. That sounds very, very exciting. Yeah, and we're looking forward to that. Of course, as one of the other cool things with Z690 and of course upcoming with AM5 is they will both be supporting PCI Gen 5 storage solutions. So an exciting time all day around on the PC platform. So with that, guys, thank you so much for joining us. Take care, take it easy, and make sure to tune in to our upcoming follow-up AMA, where we're going to have some giveaway opportunity, as well as we'll make sure to answer any remaining questions that you might have regarding maybe storage solutions, DDR5, DDR4, or whatever it might be. So take care, take it easy, and enjoy the rest of your day.
Thank you, JJ. Thank you, everyone. Take care. Bye-bye.